Hi there, my name's Jackie Decker. This video is about manipulatives and using them to build conceptual understanding. The particular focus of this video is using square tiles to help students understand integer operations. We have all met students who have memorized some of the integer rules and who have memorized them incorrectly just because they don't understand where they come from. If we begin in the concrete or revisit these operations using concrete materials like square tiles, we can help students understand the why behind the rules so that they can then apply them to harder and harder problems. What does that look like in the classroom? Well, we might begin by just getting out the square tiles, putting them on all students' desks so that we get rid of that stigma students often associate with manipulatives and help them understand that they're serious math tools that we can all use to better understand the math. And once they're on every student's desk, we might take them through a thoughtful sequence of problems to let them just represent their thinking with the tiles before we think about moving to a visual or a more algebraic representation of that thinking. If we ask students to represent +3, it helps us to have a legend deciding which tiles are positive and negative. We're going to use red as +1, blue as -1. +3 looks like 1, 2, 3. If we ask students to represent -2, they're going to say -1, -2. A little bit of practice here to make sure students are really comfortable representing number, and then we can start to worry about operation. If we ask students to represent 3 subtract 2, some students will count out 1, 2, 3. I have +3. Now I'm going to remove 2 or take away 2, and I'm left with 1. Other students might start with that +3, and they're going to see it as 3 plus -2. And they'll see this is a 0 pair because +1 plus -1 equals 0. Here's another 0 pair, and again, I am left with an answer of 1. This idea of 0 pairs is going to help us in harder problems. For example, 3 subtract 5. I can count out 1, 2, 3. If I want to remove 5, that's impossible. I only have 1, 2, 3. So I can do a couple of things here. I can add a 0 pair. I can add another 0 pair. And now I do have 5 to remove. 1, 2, 3, 4, 5. And I'm left with -2. The other thing students might do is say, well, I'm going to start with +3, and I'm going to add -5. 1, 2, 3, 4, 5. I have a 0 pair, a 0 pair, and a 0 pair, and again, I'm left with -2. If I ask students to represent 2 subtract -3, students will then count out 1, 2, and now we're wanting to subtract -3, but I don't have -3 to subtract. So if I think about that idea of 0 pairs, I can add a 0 pair, I can add a 0 pair, I can add several 0 pairs till I have a field of zeros. And now if I would like to remove -3, I can remove -1, -2, -3. This is a 0 pair, and I am left with 1, 2, 3, 4, 5 as my answer. Once students have done a lot of practice of addition and subtraction of positive and negative integers, we can move to multiplication of integers. So if we think about 2 multiplied by 3, students might think about that as 2 groups of +3. And we know that that is 6. They might think of it as 3 groups of +2 with that commutative property, which we want to notice and name for students because it becomes really powerful when the problems get more tricky. So if we then say, well, what's 2 multiplied by -3? Students will understand that we can have a group of -3 and a second group of -3, giving us that answer of -6. If we now ask students, what's -2 multiplied by -3? We're going to have some productive struggle here. This is complicated. And one way that we can help students understand is by thinking of -2 multiplied by -3 as the removal of 2 groups of -3. Well, what can we remove that from? We can remove that from a field of 0. So if we start with a number of 0 pairs, so I've got my nice field of zeros here. And now if I want to remove 2 groups of -3, here's one group of -3, I'm going to remove that. Here's another group of -3, I'm going to remove that, and I am left with 1, 2, 3, 4, 5, 6, +6. So take some time to explore the problems yourself using square tiles, and then give it a go with your students, giving them lots of think time at every step. Thanks for listening.